Hello class, we're about to start section 13.2 part 2, multiplying radical expressions. Objective 1, multiplying radicals with the same index. Multiplying radicals. You can multiply any radicals with the same index. Always simplify after you multiply. Keep the following tips in mind. Numbers outside the radical multiply other numbers outside the radical, while numbers inside the radical multiply other numbers inside the radicals. For example, we have 6 times the square root of 8x times the negative 3 square root of 6x. If you notice, the index of both of these radicals are the same, which is 2, even though it's not shown. So what we would do is multiply the outside. So we have 6 times negative 3, which will give us negative 18. And then we will multiply the two radicals. We will carry over the radical sign. 8 times 6 is 48. And x times x is x squared. Now what we would do here, we would pull out all of the perfect squares from under the radical. Now 48, the highest perfect square in 48 is 16. And we know x squared is a perfect square. And that will leave 3 in the following radical. So we will add negative 18, square root of 16x squared, give us times 4x, and bring down the square root of 3. Negative 18 times 4x will give us a negative 72x times the square root of 3. And that will be our final answer. Now we scroll down. It says, watch out for distributive laws. Now, if you notice, this is slightly different than the last example we just did. If you notice here, we have numbers on the outside, and we also have a binomial, two binomials inside of the parentheses. Now, in the other problem, which we had up here, if you notice, this was a monomial times a monomial. So this will be solved differently. So this is what we would do. First, we will see if we can combine anything inside the parentheses. We cannot. So we have to get rid of these numbers on the outside since we don't have any exponents. So we will multiply 3 by everything in this parenthesis and positive 5 by everything in this parenthesis here. So this will give us 3 times the square root of 2x, and 3 times the negative 4 square root of 5x will give us a negative 12 square root of 5x. So that took care of this first set. Now we have this positive 5 times both of these terms here. So that would give us a positive 15 square root of 5x, because 5 times 3 is 15, and we bring down our square root 5x. Positive 5 times the negative 6 times the square root of 2 will give us a negative 30 square root of 2x. Now we combine the like terms. We have 3 times the square root of 2x minus 30 times the square root of 2x will give us a negative 27 square root of 2x. Now we go here. We have negative 12 square root of 5x plus 15 square root of 5x. Now we combine these terms. Negative 12 plus 15 will give us positive 3, and we bring down our square root of 5x, and we're done. Now we scroll down here. It says, watch out for FOIL situations. So we know with the FOIL situation, we would just distribute the first term by these two terms, and then the last term by these two terms. So we would take 2 times square root of a times the square root of a plus 2 times the square root of a times the negative 3 square root b. Now we would take the square root of b. Now, of course, if you notice here, I don't have enough room. So I rewrote this a little smaller to give me a little bit more room. So we go here to the plus square root of b times the square root of a plus the square root of b times the negative 3 square root b. Now we multiply. Now we know square root of a times square root of a would just give us a. So this would be 2 times a. Now we will have 2 times -3, which is -6, and square root of a times the square root of b is the square root of ab. Now we will have plus square root of b times the square root of a, which will give us the square root of ab, plus the square root of ab. Then the square root of b times the -3 square root of b. We know square root of b and square root of b is b times -3 will give us -3b. Now we will combine like terms. We will add 2a, -6 times the square root of ab plus the square root of ab will give us a -5 square root of ab, and then minus 3b. And this is our final answer. Now remember how we got this -5 is assumed to be a 1 in front of this square root of ab, and -6 plus 1 will give us -5. So we're done with this problem. Now we come here. We have this parenthesis and it's squared, so we need to write this parenthesis twice. Now we will do our distributive property or the FOIL method in multiplying these two parentheses. So we would take, and I'll write it down here to give myself more space. I would take 4 times the square root of 3x times 4 times the square root of 3x plus 4 times the square root of 3x times -5, and then -5 times 4 times the square root of 3x, and then -5 times the -5. So we distributed all four, we distributed this first term by these two terms and the second term by these two terms. So now we multiply. 4 times 4 we know is 16. Square root of 3x times the square root of 3x we know would give us 3x. So we add 16 times 3x, which we know would be 48x. Now we would take 4 times the square root of 3x times -5, which would give us a -20 times the square root of 3x. Now -5 times 4 times the square root of 3x will give us a -20 square root of 3x. And then -5 times -5 is a positive 25. Now we brought down what 6 times 3x was, which is 48x. But we do have like terms here with the -20 times the square root of 3x. So that will give us -40 times the square root of 3x and bring down our plus 25. So all of this here will be our final answer. We can't combine anything else. And we are done with this section. So now we move on to the next section. We move on to 13.3, dividing radical expressions. Dividing radicals. Create an expression that satisfies the following criteria. No perfect nth powers under the radical. No fractions under the radical. No radicals in the denominator. Eliminate by rationalizing the denominator. How to rationalize one-term denominators. Multiply top and bottom of fraction by a fraction that creates a perfect nth power in the denominator. So we apply that down here. Look here at A and B. Okay, first we look here at A. Square root of 100 over 25. Now before we do any simplifying, we know that 100 is a perfect square and 25 is a perfect square. So we would do that first. Square root of 100 is 10. Square root of 25 is 5. And we know 10 divided by 5 is 2. So we're done with A. Now we come here to B. Now, what we could do is this here. We can actually do what we just did here. We could take the square root of, you know what, before we do that, let's simplify. Let's try simplifying first here. 400 divided by 4 we know would give us 100 in our numerator. X cubed divided by x will give us x squared in our numerator. Y over y to the 5th will give us y to the 4th in our denominator. So now we can break up this square root. It would be the square root of 100 x squared over the square root of y to the 4th. Square root of 100 is 10. Square root of x squared is x. And the square root of y to the 4th is y squared. And that is the final answer. Now we go down here to C. We have the square root of 3/5. Now we cannot simplify this and they have nothing in common. So we will break this up. We have the square root of 3 over the square root of 5. Now we have to rationalize our denominator. So we can multiply our numerator and denominator by the square root of 5. So we won't be left with a square root in our denominator. Square root of 5 times square root of 5 we know is 5. And square root of 3 times square root of 5 is the square root of 15. And that is our final answer. Now we come here to D. It's the same thing. We need to rationalize this denominator. So we'll multiply the numerator and denominator by the square root of 2x. In our numerator, that would give us 5 times the square root of 14x. All over. Square root of 2x and the square root of 2x will leave us 2x. So that is our final answer. Now we scroll down here to E and F. Now it's the same thing. We need to rationalize our denominator here. So we look here at our common denominator. Well, actually, we will multiply this by the square root of 8 over the square root of 8. Now this would give us 3 times the square root of 8 plus the square root of 40 all over 8. Now, this is what happens here. We know the square root of 40 and the square root of 8 both has a perfect square in it. So we would take 3, the perfect square in 8 is 4, and we'll be left with a square root of 2. Then plus the highest perfect square in 40 would be 4, and we would be left with 10. And this is all over 8. So now we know the square root of 4 is 2, and 2 times 3 is 6. So we have 6 square root 2 plus the square root of 4 is 2, and we have the square root of 10 all over 8. Now we know here with 6 and 2 we can factor out a 2. So let's factor out our 2. And we have in parentheses 3 square root of 2 plus the square root of 10 all over 8. Now we know 2 and 8 simplifies out. 2 goes into 2 once, 2 goes into 8 4 times. So our final answer here would be 3 square root of 2 plus the square root of 10 all over 4. And that is the final answer. Now we go here to F. Now with F, we need to rationalize our denominator. So we multiply the numerator and denominator by the square root of 6m. So now in our numerator, we will have 2 times the square root of 18mn all over 5 times 6m. Because the square root of 6m and square root of 6m is 6m. So now in our numerator, we know we have a perfect square in 18, which would be 9. And we'll be left with the square root of 2mn. All over 5 times 6m is 30m. Now the square root of 9 we know is 3, and 3 times 2 is 6. So we have 6 times the square root of 2 times m times n, all over 30m. Now we know 6 and 30 has something in common, which is 6. 6 goes into 6 once, 6 goes into 35 times. So our final answer would be the square root of 2mn all over 5. And that is our final answer. Now we scroll to the next page. We have radical conjugates, radical expressions with the same two terms, but with the opposite signs between them. That is a radical conjugate. Example, 3 minus the square root of 11 and 3 plus the square root of 11 are conjugates. The square root of 15 plus the square root of 17 and the square root of 15 minus the square root of 17 are conjugates. Now it says how to rationalize two-term denominator square roots only. Multiply top and bottom of fraction by the conjugate of the denominator, like we wrote up here.